Hi everyone, today I'm going to show you how you can solve some more complicated examples of logarithmic equations by applying what is called change of the base formula. But let's have a look at our example first. So this is our equation which we're going to solve for x. Log base 3 of x plus log base 5 of x is equal to common log of 15 over common log of 3. And this is a quick reminder, guys, whenever you come across logarithm without the base, as it is in our example, on the right hand side of the equation, this usually means that this is 10 base logarithm and it is called common logarithm. So our log of 15 is actually a log base 10 of 15, and the same thing applies to log of 3. If we want to find solutions to our equation, we need what is called change of the base formula. And the idea behind the rule is really straightforward. Let's say we have a logarithm with some base b of some argument a. Then the rule says this is totally equivalent to logarithm with some new base d of the argument a over logarithm with the base d of argument b. A good way of remembering the rule is to think of base b as of basement, which is always below, and of argument a as of additive, which is always above. Of course, there are some conditions put on a, b, and d. They all have to be positive real numbers, and additionally, b and d have to be different from 1 as they are basis of the logarithm from the formula. But let's come back to our equation now, and let's focus our attention on the left hand side of the equation. The first thing we note is that both logarithms have two different bases, 3 and 5, and this is totally unwanted. That's why we're gonna apply our above rule to the second term, which is log base 5 of x, in order to change its base from 5 to 3. So let's rewrite the equation just to make the whole concept a bit clearer. So what we're gonna do now is we wanna apply the change of the base formula, keeping in mind that b from the rule now becomes 5, a turns into x, and d is gonna be our new base 3. So let's have a look at it. So now log base 5 of x is equal to log base 3 of something over log base 3 of something else. And we know that 5 is our original base, so 5 goes to the denominator of the equivalent quotient, while x is our original argument, so a goes to the numerator. And that's it, simple as that. So now we can rewrite the second equation once again by replacing the second term with the equivalent quotient. Our next step is to apply the very same rule to the quotient on the right hand side of the equation, but this time we're going to do it in reverse order, because what we want to achieve, we would like to get rid of that quotient of two logarithms and replace it with one single 3 base logarithm. So let's rewrite the equation once again, and we're gonna simply follow the pattern from the rule, remembering that b from the formula now turns into 3, d is gonna be 10, and a becomes 15. Let's have a closer look at it. So now we can say log base 10 of 15 over log base 10 of 3 is equal to log with some base of some argument. And because 3 is in the denominator, it becomes our base of equivalent logarithm. And from the same reason, because 15 is in the numerator, 15 becomes argument of the equivalent logarithm. And now we can rewrite the last equation by replacing the quotient with the 3 base logarithm. In order to carry on with solving our equation, we need 3 more log rules, and these are multiplication rule, which says multiplication inside the logarithm turns into addition outside logarithm, and vice versa. Please note that both logarithms have the same base b, and if the bases were these two, we wouldn't be allowed to apply the rule. The second one is cancelling exponent rule. If we have logarithm and exponent with the same base, then they cancel each other, and we end up with a power, an index of the exponent. So log base b of b to y is equal to y. And the last rule states if we have two logarithms with the same base, one on either side of equal sign, with coefficients of 1, then we can drop logarithms and the equality for the arguments a and c still holds. Of course, there are some conditions put on a, b, and c. They all have to be positive real numbers, and additionally b have to be different from 1 as it is based on the logarithms. So let's come back to our equation now. First we apply multiplication rule to the logarithm on the right hand side of the equation. We just follow the rule turning multiplication inside logarithm out into addition outside logarithms. Now we would like to get rid of that denominator on the left hand side of the equation, and we're going to do it by multiplying both sides of the equation by log base 3 of 5, which gives us log base 3 of x times log base 3 of 5 plus log base 3 of x is equal to 1 plus log base 3 of 5 in brackets times log base 3 of 5. Now there is a common term on the left hand side of our equation, so we factor it out. After that, we note that there is a common expression, common sum on both sides of the equation, so we reduce it, we cancel it by multiplying both sides of the equation by the term, by the expression, which leads us to conclusion that log base 3 of x is equal to log base 3 of 5. And finally, by applying the last rule to the last equation, we drop logarithms and get final solution, which is x is equal to 5. Of course, we need to make sure this is really a valid solution to our original problem, and in order to do it, we need to substitute 5 for x in our original equation. But I'm not gonna do it. This is gonna be your homework, just so that you could have some practice with logarithms. And that would be it. Thank you for watching. New examples are coming soon.